I am Siddharth Kumar Gopal, studying in Standard 5 at St. Thomas Residential School. We all know that when we blow a candle, it blows off. But what if we blow it behind an obstacle? For this, we need a rectangular box, a cylindrical box, a lit candle and a hair dryer. The hair dryer is not mandatory. We can even blow with our mouth. I am just using the hair dryer to ensure the same air stream. Now I am going to place the rectangular box in front of the candle. I am going to blow it with the hair dryer. Now I am going to blow the air. Now as you see, the candle has not blown up. Now let us see with the cylindrical box. Now I am going to blow the air. Now, as you can see, the candle has blown off. This is due to the Coanda effect. The Coanda effect is the tendency of a fluid jet to get attached to the convex surface. So when we blow air, the air gets attached to the convex surface and reaches the candle and blows it off. In the case of the rectangular box, the air goes and touches the edges and scatters off without reaching the flame. This is the Coanda effect. Now I am going to show you the Coanda effect, which can be better seen in a jet stream of water. For this, you need a cylindrical pen and a rectangular ruler. First, I am going to on the tap to make a jet stream of water. Now I am going to cut the water stream with a rectangular ruler. As you can see, my hand is not getting wet when placed directly under the scale. But when I cut the jet stream with a cylindrical pen with a convex surface, let us see what happens. As now you can see, the water attaches itself to the convex surface, and when I put my hand directly under it, my hand gets wet. This is due to the Coanda effect. Just as you saw, when I kept my finger under the rectangular ruler, it did not get wet. In the same way, the air did not reach the flame